So carboxylic acids. So we're starting with properties of carboxylic acids. So this is a little bit of National 5 and higher revision. So carboxylic acids are homologous series with the general formula CnH2n plus 1 COOH, and they contain the carboxyl functional group. They have relatively high boiling points due to the presence of hydrogen bonding between the carboxylic acid molecules. Now, this is the bit that's very much new to advanced higher, and it's quite specific to carboxylic acids, and it's something that's quite strange with carboxylic acids. What we can see is as the number of carbon atoms in our carboxylic acid chain increases, the melting point actually decreases, which is, or kind of tends to decrease. The melting points are a little bit wacky with carboxylic acids. You can see it goes from 8 up to 17, then down to minus 21, then up to minus 5, and then down to minus 34. So the melting points are kind of a wee bit all over the place with carboxylic acids. But the kind of strange trend that we see with the melting points or in carboxylic acids is because as the number of carbon atoms in the carboxylic acid chain increases, the extent of the hydrogen bonding between the molecules decreases. So this means it's common for longer chain carboxylic acids to have lower melting points than those with shorter chains. It's not a resolute fact because, as you can see, ethanoic acid has a higher melting point than methanoic. Butanoic has a higher melting point than propanoic. It just very much depends. So it's not uncommon. That's the kind of key thing. It's not uncommon to see these irregularities in the melting point of carboxylic acids. Now, the reduction in the extent of hydrogen bonding with longer chain carboxylic acids also affects its solubility in water. As the number of carbon atoms in the chain increases, the solubility decreases. Okay. So that means pentanoic acid will be less soluble in water than methanoic acid because it is less polar. Okay, so for the next bit, we're looking at preparation of carboxylic acids, and this is all revision. So carboxylic acids can be prepared in a number of different ways. So to begin with, we can oxidize a primary alcohol or an aldehyde, and this reaction is carried out with an oxidizing agent such as Benedict's, Tollens reagent, hot copper oxide, or acidified potassium dichromate. So for example, what I'm going to do is take the primary alcohol ethanol. We are going to oxidize that to an aldehyde, which would be ethanal in this case. And then we are going to further oxidize to our carboxylic acid, which would be ethanoic acid. Like so. The next way of preparing a carboxylic acid is to hydrolyze a nitrile. This is one of the most important reactions that we do in chemistry. So if we take a nitrile, now nitriles are substances that have a carbon to nitrogen triple bond. We only look at them in a tiny part of the course. Now this reaction happens with an acid catalyst and water. So it's an acid catalyzed hydrolysis. So I'm going to pop the H plus ion in, which is what all acids contain, and the water. And what we do is we break the carbon to nitrogen triple bond and replace it with a double bond O and an OH, creating your carboxylic acid like so. We can also hydrolyze esters. This is revision from higher. So this reaction is carried out with an aqueous alkali catalyst and water Now we can actually see an aqueous alkali or acid catalyst in water. Now I'll be specific and I'll say dilute acid. So if we take an ester, I'm going to try and keep this nice and short. So I'm using methyl ethanoate as my ester in question. We need to add water because we need water for a hydrolysis reaction. And what will happen is the ester link will break, that's between the carbon and the oxygen single bond. The alcohol side will have a hydrogen from the water returned, recreating the hydroxyl group. And then the acid side will have the other hydrogen and the oxygen from the water returned, recreating the carboxylic acid. So there's your carboxylic acid being regenerated. And then our final way of preparing a carboxylic acid that we deal with at Advanced Higher is hydrolyzing amides. And again, this is revision from higher chemistry, from the proteins topic. And again, this reaction is carried out with an aqueous alkali catalyst. And again, we can see or dilute acid. So for example, I'm going to take an amide. This will also remind you about what an amide looks like. So amides have that amide link, which is the C double bond O beside the NH. Again, we are reacting this with water. And in this reaction, we will break the amide link between the carbon and nitrogen single bond. Which will give us our C double bond O, and then the OH from H2O will attach, reforming your carboxylic acid, and then the other hydrogen will reattach to the nitrogen, which reforms your amine, reforming that amino group, like so. Okay, so that is us now finished with today's lesson in terms of new content, so ethers and carboxylic acids. I'm just going to stop the recording there.